Here we have three forces which are in equilibrium, so we can use Lami's theorem. We know this angle here is 15 degrees. If I continue this line across here and form a right angle triangle, this one here then is 75 degrees, plus the 90 tells me this angle here is 165 degrees. If I form a vertical here, then I can see that this angle is 15, then we have a 90, and then we have theta. So this angle here is 105 degrees plus theta. This angle here, since this is a right angle, would be 90 minus theta. So by Lami's theorem, we have that t over the sine of 90 minus theta is equal to 1000 over the sine of 165 degrees, which is equal to 300g over the sine of 105 degrees plus theta. Let's see if we can find theta first. So let's use this one equals this one. We've got 1000 over the sine of 165 is equal to 300g over the sine of 105 plus theta. That means that 1000 times the sine of 105 plus theta is equal to 300 times g times the sine of 165 degrees. Therefore, sine 105 plus theta is equal to 300 times 9.8 times sine 165 all over 1000. Calculating, this gives us 0.7609 and so on. And if we do shift sine of this, we get the acute angle 49.5 degrees. However, it should be clear, since the angle we want is 105 plus theta, that we want the associated obtuse angle. Remember, we have A and S. If we've got 49.5, there'll be another angle here, which has the same value for the sine. So we do 180 take away 49.5, and we can see that 105 plus theta would be equal to 130.45, and that gives us that theta is 25.5 degrees, correct to 1 decimal place. We can now go ahead and find t. Let's use this one and this one. So we have t over sine 90 minus theta, but of course we now know the value of theta, is equal to 1000 over the sine of 165 degrees. So t is going to be 1000 times the sine of 64.5 and so on. I'm using more decimal places than I gave here, over the sine of 165 degrees, and that calculates to 3,488.7 newtons to 1 decimal place.